And then without further ado, I'm actually going to hand over to Guy Marks to take us on our first topic of the bushfires and other challenges. So, Guy, over to you.
Thank you very much. And thanks for giving me the opportunity to talk about this. As I said, I'm a respiratory physician and epidemiologist, and the organisation that I didn't refer to earlier on is CAR, which is the Centre for Air Pollution, Energy and Health Research, which is a CRE that deals with air pollution. And Christine Cowie is my colleague from there. And I'm going to talk to you a bit about the first of these. I'm sorry, I've actually put up the wrong. Anyway, I'm going to talk to you a bit about the first of these episodes that occurred during the bushfires during this year of our catastrophes. We first of all had the bushfires, and now we've had coronavirus. So I'm going to be talking to you a bit about the bushfire catastrophes that have happened this year. But before I do that, I want to talk a little bit about air pollution in general and its effects on health. We know about this from a range of different types of studies, but the main studies, the most important study that tells us about the effects of air pollution on health is a study known as ESCAPE, a European study of cohorts for air pollution health effects. And this was a study where people got together information from pre-existing cohorts, mainly European, but in fact, some, like many European things, they tend to colonize the rest of the world. And it included, in fact, some studies from North America and from Australia. What was done was to look at a method for estimating air pollution exposure at people's residential address using what's known as land use regression. It's a method for estimating air pollution from a range of a set of different samples of air pollution concentrations, and then merging that information together with information that had been collected from a whole lot of population studies. And then you do basically a meta-regression, a bit like meta-analysis. You bring together data on air pollution with data on population studies. And this was a very large study, 13 countries, 22 cohorts, over 5 million person years of exposure. And in this period of exposure, 29,000 people died from natural causes. So this gave quite a lot of information about mortality and air pollution effects. This is a forest plot of the sort that you would be used to seeing from meta-analysis. Each line represents one of the cohort studies. And the bottom line down here represents the summary estimate of effect. Small, but statistically significant effect of, in this case, particulate air pollution, PM2.5, fine particulate air pollution, causing an increase in mortality. And so there was a significant, statistically significant increase in all-cause mortality associated with PM2.5, although other air pollutants in this study did not show effects on mortality. This ESCAPE study, a whole series of papers were published on a range of different endpoints, and they included, and I've summarized them for you in this one slide, which shows the range of different outcomes that were estimated in using the same methodology that I've just described there, and whether or not there were statistically significant associations with any air pollutants. And the main air pollution associated adverse effects were for particulates, PM2.5, that's fine particles small enough to enter into the lower respiratory tract. particulates here. PM stands for particulate matter. Nitrogen dioxide, which is largely associated with combustion of fossil fuels, particularly traffic here. And so they were the main pollutants for which adverse health effects were seen. And the main outcomes that were associated with them were deaths, overall mortality, heart disease, acute coronary syndromes, lung cancer, particulate matters associated with increased risk of adenocarcinoma, pneumonia, and lung function impairment in relation to nitrogen dioxide. Low birth weight, so not all things that you would have thought about in the past, and blood pressure. So that study is one of many, but probably the most important to show summarize the overall, what we know about the overall health effects of air pollution. This study uses data from, this slide uses data from that study and many other studies to summarize the effect of various environmental and lifestyle exposures, if you like, risk factors, for the global burden of disease. So this comes from a study you may have heard of, the Global Burden of Disease Study, a massive international effort which is regularly updated and published in The Lancet. And this is part of that study which summarizes the effects of various exposures on the burden of disease. Burden of disease being quantified as being a summary measure for the impact of risk factors on mortality, on deaths, and on disability, the sum of deaths and disability. And what it shows is that overall household air pollution, that is indoor air pollution from mainly from combustion of solid fuels, and ambient particulate air pollution are very high up on this list of pollutants. What we're talking about today is ambient air pollution. And you may surprise you to see that the major part of the burden of disease due to ambient particulate air pollution is in fact not respiratory, but cardiovascular. This sort of mid-blue color here is cardiovascular and circulatory diseases. This part here is the respiratory part. This part is the respiratory part. This light blue part is chronic respiratory disease, COPD and asthma. This is pneumonia. This is cardiovascular disease, and this is cancer. So now I want to turn on to bushfires. There is much still to be learnt about the recent bushfires, and I'll talk a little bit about the recent bushfires at the end of this talk, but most of what we know about the effect of forest fires and or bushfires on health, we know from analysis of events before the 2019-2020 bushfires. And much of this work is owed to my colleague also from CAR, Faye Johnston, who's based in Tasmania. Many of you may know. Faye and Jeff are both who's from Sydney, have done a lot of this work, a lot with Bin Jalaluddin. So this was an analysis that they did of forest fire events and emergency department attendances in Australia in this decade from some time ago. And this was a case control study in which they identified days in which there were a lot of emergency department attendances and compared them with days when there were not so many emergency department attendances. And you can see here that there's a lot of variation in emergency department presentations over the course of years. Mainly, of course, the increase in winter presentations with respiratory infections. These show the smoke event days superimposed on the variation in emergency department attendances. So the blue dots are the smoke event days, the fire days. And what this shows, and I apologize for the large number of numbers, and I'll take you through very quickly. What this is showing is how different types of presentations all presentations with respiratory illness, presentations with asthma, presentations with COPD in various age bands, all ages, children, adults aged 15 to 64 and older adults. And the lagging means to what extent this occurred on the same day as the smoke event day, the day after the smoke event day, 2 days after the smoke event day, or 3 days after the smoke event day. And what this mainly shows is that the smoke event days were most strongly associated with asthma. Here's asthma, and the bold ones show that for over the whole group, there was a substantial increase in the risk of presentation with asthma, particularly in adults, not actually in children, but in adults. We saw the increase in asthma presentations on smoke event days, and it lasted for at least 3 days after the smoke event day. Even at lag 3, there was significant increase in presentations with asthma. That was not seen for cardiovascular events. So for emergency department attendances, in contrast to the data I showed you earlier with particulate air pollution, which was mainly impacting on cardiovascular disease, smoky events from bushfires mainly impact on people with asthma in terms of emergency department presentations. And this was a similar analysis for hospital admissions. We go from emergency department attendances to hospital admissions. And here you see in Sydney, particularly an increased risk of presentations on the same day as the of hospital admission, with respiratory illness, hospital admission with respiratory illness on the same day as the bushfire event or the smoke event, and on the day afterwards. Not seen, again, for cardiovascular endpoints. This study summarizes all of the information on mortality and disability, and looks at the estimates of the impact of forest fires, again in the Sydney area, on the burden of disease. Over this 12-year period from 2001 to 2013, there were 184 days on which there were landscape fires, and it was estimated that this caused 197 premature deaths and 787 hospitalizations due to respiratory disease over this period of time. Not a huge number, but nevertheless, that's the numbers that you come up with for landscape forest fires and their effects. Of course, the episode that we're all interested in is this huge episode that occurred at the end of last year and the beginning of this year. And everybody knows we were surrounded by smoke. This is some photos that my colleague Christine Cowie took to record the events. They were a massive event for us. I quite like this series of photos. And this is a record of information from the New South Wales Department of what's now called Planning and Industry and Environment, used to be called OEH, where they show the particulate PM 2.5, again, fine particle pollution levels during the period October to January. This incredibly long period of very high levels of air pollution. This is the WHO and Australian standard for 24-hour average PM 2.5, and we exceeded that on many days during this period, massively exceeded it on several days. And again, my colleagues, Jeff and Faye and Jarl and others have put together this analysis of what would be expected to be associated with this bushfire event. I emphasize that at the moment, we still haven't got the data that allows us to analyze what the actual impact of the event is, but based on the known associations between particulate air pollution and mortality, it's possible to estimate what you would expect. This is population weighted average PM 2.5 concentrations in southeastern Australia in relation to the 25 micrograms per cubic metre standard. And you can see, again, large periods in which we exceeded that standard. They looked at smoke affected days when the air pollution 24-hour mean level was above the usual, and looked at the information, known exposure response relationships to estimate adverse outcomes over this 19 weeks of continuous fire activity that we all experienced. And essentially this is their estimate, published just recently in the MJA, of what was expected to be the excess deaths, excess hospital admissions, excess for cardiovascular and respiratory, and excess emergency department attendances that you would expect to arise from the bushfire event season. So bottom line is 417 excess deaths across southeastern Australia. So this is, as I emphasise, predictions. As yet, we haven't been able to do the analysis which shows what actually occurred, and it will be very interesting to see to what extent that occurred. I think there are some significant questions still to arise. We would like to know whether or not bushfire smoke has the same toxicity as ambient fossil fuel derived particulates. So we're making the assumption that the particulates that we measure in cities in the normal event, which are derived from fossil fuels, have the same toxicity as smoke from bushfires. We'd like to know a lot more about the effect of prolonged exposure to bushfire smoke. We'd like to know more about how this affects particularly vulnerable populations, pregnant women, the elderly, children, people with pre-existing lung disease. And we'd like to know more about whether it's possible to, what advice we should be giving to people during these episodes. Many of us were asked, and I'm sure you as GPs were often asked, what should we be doing? And there really are very few data that allow us to give good advice about what you should be doing during these episodes. So I'll finish at that point, and I'll be happy to answer some questions.
Guy, thank you so much for an absolutely excellent presentation, and that really is very, very informative. And I think obviously leaves a lot of things in the air that we still don't know the answer to. I mean, Kerry, what's your thoughts and your experience as a GP in the front line of the impact of bushfires on your patients or your colleagues' patients?
Well, we certainly had the bushfire smoke here as well. In fact, we got some of it drifting across from the New South Wales bushfires and Victorian bushfires, but we had our own bushfires here in the hills and Kangaroo Island. And it was really obvious that our patients with chronic respiratory illnesses, asthma and COPD, were much more symptomatic. You know, we were seeing a lot more patients coming in because of flare-ups of their, anecdotally, we didn't document it, but people were just saying it. When the bushfire smoke was here, my breathing was worse, and I was coughing more, and so it was quite bothersome. I mean, it wasn't as dramatic as what I know it was in Melbourne or in Sydney in particular, but it certainly was quite noticeable. The effect on asthma in particular, it seems to be.
And I was going to ask Joe the same question on the outskirts of Sydney. I don't know whether you're still there, Joe. Maybe you could put your video back on and give us maybe your experience too, because I know there was quite a lot of impact, not necessarily from the 2020 ones, but 2019 you had quite a big impact. So Joe, are you there?
We found that there was an increase more in the COPD, but I think it's an individual thing. Obviously in Sydney, where I work, I think the bushfires definitely caused more patients anecdotally to come in. with asthma and COPD. But again, don't have any hard sort of figures in how much that came in.
And then, Guy, I guess that question from the front line then as well in terms of hospitalised patients, what was the impact that you saw?
Look, I think actually we were surprised about the limited impact. Just at, anecdotally, I think my colleagues at Liverpool were relatively surprised that they didn't see a huge increase in presentations. And I think others who may want to comment on this, but the story that I heard from colleagues was that they were seeing patients who complained of irritation and discomfort and relatively mild symptoms, but not causing severe exacerbations. But I think I'm always reluctant to sort of rely, if you like, on the sort of anecdotal experience, and I like to see what the data showed. So I'm looking forward to seeing the analysis of the data on mortality and on hospital presentations and on ED presentations, because we can, just as we will with the COVID, we can get we have very good data, of course, in Australia on this sort of thing, and we will be able to. We have very good data, but it takes a long time to get access to it, and that's the downside. But we will, I think, eventually be able to say a little bit more about this, and I'd rather rely on that than on sort of what I would report as the anecdotal experience. I've just put up another slide that I'd meant to show, and I messed up my presentation at the beginning. But if you just give me one moment, I know that people are interested in this audience about what advice they can, and I showed earlier that, asthma presentations seem to be the greatest risk, and what advice. The reason I've also been a bit reluctant to sort of share this advice, because there are very few data that allow us to validate this advice, but it is the questions that we were all asked many, many times during the summer. Is what advice can we give people? And for what it's worth, this is the advice that I was giving, and I think most of my colleagues were giving as well, which is not very spectacular. It's basically common sense that you should continue with your regular treatment, that you should avoid exposure where possible. We've been looking at the question of what you can do in the indoor environment to make it safer. That you should avoid strenuous exercise, and that you should manage symptoms and exacerbations as usual. And we weren't sure about the role of masks. Many of these things are being currently investigated with research that's going on at the moment. It's stimulated a lot of questions and a lot of research. And I think we'll be hopefully better prepared the next time this comes around.
So I've got some questions coming in here. So in terms of pollution, which was raised early on in your talk, any difference between diesel and petrol? Because there's a lot of towns around the world that have banned diesel cars, etc. And I just wondered what the story is there, Guy.
Well, diesel exhaust particulates have actually been studied more directly than petrol combustion engines, but both in fact produce particulates and both cause adverse effects. We know this from studies where people have been exposed in exposure chambers directly to the emissions from engines, and also we know it from the epidemiological studies. And most of the data that we have on the effects of particulates and nitrogen dioxide, traffic-related pollution is a major contributor to that. But at one point, diesel engines were being promoted as being, more environmentally friendly. That's probably not the case. There's no evidence to suggest that diesel's more environmentally friendly, but whether it's less environmentally friendly and less good for health is unclear. What probably matters more is what the emission controls are. So whether you're at this called Euro 5 or Euro 4, Euro 5 and Euro 6 it's really the emission controls on the engines. In Australian cities, most of the emissions from diesel engines come from trucks, and particularly old trucks, old smoky trucks that have, because trucks seem to be stay around for a lot longer. People use trucks for decades. So the engines that are on the roads for trucks now are all very old and have poor emission controls and poor quality. Modern cars are have much less emissions than older vehicles.
Thank you. I've got another question here coming up about sugarcane burning that happens in certain areas, and some farmers have stopped it, some haven't. And I'm sorry, I'm not giving people's names out here because the recording of this will be available online, so we didn't want to have people's names on the recording. But
it's a very interesting question, and it's a big issue. Agricultural burning, you see in Queensland. I'm assuming that person comes from North Queensland. But in the rest of the world, it's very common. I was in New Delhi just before our bushfires last year in October, and you may remember there was a lot of coverage about massive air pollution in New Delhi, and I happened to be there at the time, and it was incredible. It wasn't as bad as we saw in the bushfires here, but it was bad, and that was mainly from agricultural burning. So burning of agricultural burning is a cheap way of avoiding having to plow. Basically, it's a cheap form of agriculture, and many countries use it, including sugarcane burning, and it causes massive levels of particulate air pollution, essentially, and often it moves over long distances, and that's what happened in India. They weren't burning in Delhi; they were burning in nearby, and the air pollution was coming over New Delhi and caused huge exposure of the population. And the same thing happens in North Queensland. It also happens, forest fire burning in Indonesia is a huge thing, and that's basically deliberately lit fires to clear land, so it's a major problem.
And I've got another question here about about delayed effects of particulates exposure in terms of COPD and lung cancer. Do we have any data on that, or when would we expect to see that sort of data and those sorts of effects?
Well, if you're talking about in relation to the bushfire, there are data to suggest that prolonged exposure to high levels of particulates are associated with increased risk of lung cancer, less for COPD, but certainly increased risk of adenocarcinoma. And I showed a slide that looked at that from the ESCAPE study. Most of the air pollution that's being that is causing the particulate levels that were studied there is urban ambient air pollution, which is mainly traffic and industry. The effect of whether or not that also happens from vegetation burning, as in forest fires, remains unknown. It's an unclear, and I think it'll be very difficult to establish that from epidemiological studies. But I think people are looking at that in vitro, basically, in animal studies and in cell-based studies, where it's possible to see whether the smoke derived from burning of vegetation causes the cellular abnormalities associated with lung cancer. I think that will be interesting, and that is being looked at as we speak.
I've got one really interesting question here, and I mean, we're all increasingly aware, and I think Kerry will probably talk about it later on today, that acute exacerbations of COPD are often associated with increased risks of myocardial infarction in the months afterwards. And I just wondered whether there was any similar such data for bushfire exposure in terms of increasing the risk of acute MI, both through the respiratory route, and obviously you talked about the fact that actually there's a direct impact in itself. So just wondered about that.
Well, as I showed in one of the slides, you know, that the analysis of the previous bushfires or smoky days in Sydney and in Australia did not show much of a signal for cardiovascular disease, including heart attacks. That contrasts with particulate air pollution from ambient sources, from traffic and industry, for which the main adverse effect is in fact cardiovascular disease. So that's an interesting contrast. This forest fire, this bushfires that we had in southeastern, earlier this year were a unique event, and really it will be very interesting to see what impact they had. They may well be different to what we learned from the previous fires because of how prolonged it was. We're normally looking at events that last for a day or so, or a few days, but 19 weeks of continuous exposure is a remarkable event, and we just don't know what the impact of that is at the moment.
And I think that is the big question. And I think building data, as you said, is really important. And one of the things that I think we'll talk a lot about as the day goes on is actually how we might build better data as well. So that might be a great discussion later on. Guy, I'd like to draw that session to a close. A great start to our day. Thank you so much for presenting that so clearly and so well. And I think we're going to have there's still plenty of questions. I'm sorry I couldn't answer them all, but we will try and answer some of them on the Q&A panel for you as well, or afterwards. So thank you very much.